friends, let us discuss about the subject Basic Numerical Skills. Our first module is Set and Set Operation. Our first topic is Set. So what do you mean by set? It's just a very simplest topic to grasp in mathematics, since we have to talk the just three simple questions. Our first question is, what are sets? Our second question is, why do we need them? And last, how do we represent them? So let's start the first question. What are sets? Set is basically a collection of things. Think about it. What if you were asked to make a list of all the things you can see? Of course, you can't write all the things. But some of the things you will mention are a tree, a cell phone, a puppy, people and so on. And what if you were asked to write down a list of things that you cannot see? You will probably write oxygen, heat and so on. So these are the things that you cannot see. So a set is a collection of elements? Yes, but they have to be related in some way. Okay, so let us look a few more examples to understand better. So try to list down all the cricket playing nations you know of. If I will probably have said India, England, Australia, Pakistan, etc. Now try to list all the oceans that you heard of. If you didn't know, there are 5 oceans in this world: Pacific, Atlantic, Indian, Southern, Arctic. Now here is an interesting question. Can we make a set of elements for all the questions you are asked for? The answer is no, not necessarily. But if you were asked to make a list of good teachers we know, we cannot make a set here, because my idea of a good tutor may be completely different from yours. So similarly, we cannot make a list of the intelligent students that we know. So the word intelligent is not well defined. So remember guys, another important characteristic of set is that the element in it should be well defined. All the elements in the set should be related and well defined. Next we discuss about their representation. So how to represent a set? A set is represented in 2 ways. First of all, roster or tabular method. The second one is set builder method. So what do you mean by tabular method? In this method, a set is described by listing the elements separated by commas and are enclosed within braces. So for example, the set of the first 3 odd numbers 1, 3, 5 is represented by A is equal to set of 1, 3, 5. Okay, is it clear? Next we discuss set builder method. So what do you mean by set builder method? Here the set is represented by specifying the characteristic property of its elements. For example, the set of natural numbers between 1 and 25 is represented as A is equal to set of x such that x element of n and 1 less than x less than 25. Next, discuss about types of sets. Here, first type is empty set or null set. A set which does not contain any element is called an empty set, or the null set or the void set, and it is denoted by the symbol. Okay, for example, the set of natural numbers between 4 and 5. Here there is no natural numbers in between 4 and 5. So this is a null set. Next, singleton set. So what do you mean by singleton set? That is, a set which contains only one element is called a singleton set. For example, B is equal to set of x such that x is a whole number. That is x less than 1. So this set contains only one element, that is 0, and is a singleton set. Okay. Next, finite set. So guys, what do you mean by finite set? A set which contains a definite number of elements. That is called a finite set. For example, the set of all colors in the rainbow. This is a finite set. Why? Because we have the colors in rainbow that we know. That is VIBGYOR. Okay. Next, infinite set. So what do you mean by infinite set? That is the set whose elements cannot be listed. That is, set containing never-ending elements is called an infinite set. For example, set of all points in a plane. Here, there are a lot of points in a plane. So this is not finite. So this is infinite set. Next, equivalent set. Here, two sets A and B are said to be equivalent if their cardinal number is same. That is, n of A is equal to n of B. Okay, the symbol for denoting an equivalent set is here. For example, A is equal to set of 1, 2, 3. Here, n of A will be 3. Okay, next set B is equal to set of P, Q, R. Here also n of B will be 3. Okay, therefore A equivalent to B. Next, equal set. So what is equal set? Two sets A and B are said to be equal if they contain the same elements. That is, every element of A is an element of B and every element of B is an element of A. For example, A is equal to set of 1, 2, 3, 4 and B is equal to set of 2, 3, 1, 4. Here, therefore, A equal to B. Why? Because all the elements that contain A, set A is equal to every element contained in set B. Okay. Next, power set. So what is power set? The collection of all subset of set A is called the power set of A. It is denoted by the letter P of A. In P of A, every element is a set. For example, take for A, set A is equal to set of 1, 2, 3. Then power set of A, that is P of A, will be a null set first, then set of 1, 2, 3, then set 1, then set 2, then set 3, then set 1, 2, then set 1, 3, then the last set is set of 2, 3. Next, universal set. So friends, what do you mean by universal set? A set that contains everything? Yes, it does. But it should be suitable. So what is suitable? Look at these three sets. Set A is equal to set of X such that X is a student of class by A. Next, set B, that is equal to set of X such that X is a student of class 5B. Next, C, that is set C is equal to set of X such that X is a student of class 5C. Here, we assume there are just 3 divisions of class 5. So, what do you think will be the universal set? It's denoted by capital U. The universal set here will be U is equal to set of X such that X is a student of class 5. So you could have said that the universal set is the set of all students in your school or set all in the world. Okay, so but that would not be correct. The set of all students of class 5 is more suitable. Disjoint set. So what is disjoint set? And here, that is two set A and B are said to be disjoint set if no element of A is in B and no element of B is in A. Take for example, set A is equal to 3, 4, 5 and set B which is equal to 6, 7, 8. Here A which is not equal to B, that is disjoint set. Why? Because in set A we have 3 elements, 3, 4 and 5. Okay, in the next set B, we have the elements 6, 7, 8. Both sets are not equal. That is, here set no element of A is in B and also no element of B is in A. So, these are disjoint set. Next, set operations. Here we first discuss about union of sets. The union of two sets A and B is the set of all those elements which belongs to A or to B or to both. For example, if A is equal to set of 1, 2, 3, 4, then set B is equal to 3, 4, 5, 6. Then A union B, which is equal to set of 1, 2, 3, 4, 5, 6. Here we know repetition is not allowed in set. Next, intersection of set. The intersection of two sets is the set consisting of all the elements which belong to both A and B. It is denoted by the letter just C. Take for example, if A is equal to set of 1, 2, 3, 4, then set B is equal to 3, 4, 5, 6. Then A intersection B, which is set of 3, 4. Here we can see the elements 3 and 4, which is also elements of A and B. Next, difference of two sets. The difference of the two sets A and B is a set of all elements in A which are not in B. It is denoted by A minus B or A by B. Take for example, if A is equal to set of 1, 2, 3, 4, then set B is equal to set of 3, 4, 5, 6. Then A minus B, which is equal to set of 1, 2. Here we know in set A we have the elements 1, 2. Balance 3, 4 is also elements of B. So just cut it. Next, complement of a set. Complement of a set is the set of all elements belonging to the universal set but not belonging to A. So it is denoted by A complement or simply A dash. So we have A complement, which is equal to U minus A. Take for example, U is equal to set of elements having set 1, 2, 3, 4, 5. Okay, then we have a set that is A. A is equal to set of 1, 3, 5. Then A complement becomes U minus A, that is set of 2, 4. Topic is laws of sets. First law is commutative law. For any two finite set A and B, if A union B, which is also equal to B union A. In the second law states that A intersection B, which is equal to B intersection A. The second law is associative law. So for any three finite set A, B and C, first of all A union B union C, which is equal to A union B union C. The second one is A intersection B intersection C, which is equal to A intersection B intersection C. Thus, union and intersection are associative. The third law is idempotent law. So what is idempotent law? It states that for any finite set A union A, which is A, and A intersection A, which is also A. Fourth one is distributive law. That is for any three finite set A, B and C, A union B intersection C, which is equal to A union B intersection A union C. The second one is A intersection B union C, which is equal to A intersection B union A intersection C. Is it clear? Next, De Morgan's law. Here for any two finite set A and B, first of all A minus B union C, which is equal to A minus B intersection A minus C. Second one is A minus B intersection C, that is in case of intersection, okay, that is equal to A minus B union A minus C, okay. Next, De Morgan's laws can also be written as A union B complement, which is equal to A complement intersection B complement, and the second one is A intersection B whole complement, which is equal to A complement union B complement.